This is our second lesson on momentum. In this lesson, we're going to cover the law of conservation of momentum and collisions. The law of conservation of momentum is a fundamental and universal law in physics. It is always true and always applies. It states that for a collision between objects in an isolated system, the total momentum before the collision is equal to the total momentum after the collision. So if we look at our snooker balls on the right, the total momentum of those two snooker balls before the collision is equal to the total momentum of the two snooker balls after the collision. This also applies to the Newton's cradle at the bottom, the two cars in the accident, as well as the roller skating collision on the left. And when collisions occur, the momentum of one object is passed on to the other, and overall momentum is conserved. It's a really important word, that. Momentum is conserved. That means it stays the same. Let's take a look at this clip to see how momentum works in space.
Conservation of momentum tells us that the total momentum in any closed system will remain the same all the time. And since momentum is equal to mass times velocity, even if you have multiple objects going at different speeds that might collide, for example, the total momentum of the system before and after the collision will remain constant. So, for example, these two balls, which in this case happen to be of equal mass, whether one of them is moving, it causes the other to move, or they're both moving and collide and move off in different directions, the total speed and the total mass of the entire system always remains the same.
Because the total speed and the total mass of the overall system remains the same, momentum is conserved, and the law of conservation of momentum applies.
For example, if this had a velocity of 0, and that had a velocity of 1, the first one might impart some of its momentum onto the second, but the total between the two remains the same. And that remains the same whether one remains still and the other comes to collide with it, or whether they're colliding with each other.
Remember, total momentum before the collision is equal to total momentum after the collision. That's the really important thing to get. Let's take a look at this next example he's about to show us.
It works. In this case, I put Velcro. It even works if these two stick together.
The collision between objects which results in them sticking together is a very, very common exam question. Let's take a look and see how this works mathematically. So in this question, two cars collide together. A silver sports car collides into the back of a green family car and sticks to it. Work out their speed after the collision. So it's really important to note that the two cars are now stuck to each other after the collision. So we have our green family car, which is moving at 20 meters per second to the right. And we have our silver sports car moving at 50 meters per second to the right as well. The green family car has a mass of 800 kilograms, and our silver sports car, has a mass of 1,000 kilograms. What we can see right here is the two cars before the collision. After the collision, it'll look something like this. Now the two cars are stuck together and moving at a certain speed. We need to work out what that speed is. But before we do that, let's think about the total mass of these two cars together, and that is 1,800 kilograms. Because they're stuck together, we can think of them as one body, one object. So Before we begin to work this out, let's recall what we've learned already about momentum. Firstly, momentum is equal to mass times velocity, and our law of conservation of momentum states that during a collision, initial momentum will be equal to final momentum. Now let's put this into practice. First, we're going to separate these two instances. We're going to separate before the collision and after the collision. So we need to work out the total momentum of these two cars before they collide. So we need the momentum of the silver car plus the momentum of the green car. Now, we can recall that momentum is equal to mass times velocity. And we know the mass of the silver car is 1,000 kilograms. And it was moving at 50 meters per second. So our initial momentum of the silver car, we can put this into our calculator and find that it's 50,000 kilogram meters per second. On the other hand, we need to calculate the momentum of the green car. And again, we know that momentum is equal to mass times velocity, as our mass is 800 kilograms. You can put that in here. And it's moving at 20 meters per second. So our initial momentum of the green car is 16,000 kilogram meters per second. So our total initial momentum is equal to 50,000 plus 16,000, which is 66,000 kilogram meters per second. And that's our total initial momentum. That's the momentum of the two cars, both cars, before they collide into each other. Now, according to the law of conservation of momentum, our initial momentum before the collision is equal to our final momentum after the collision. Now, based on that, we know that the momentum of these two cars together after they collide is equal to 66,000 kilogram meters per second, because momentum is the same. Remember, initial momentum is equal to final momentum. Let's put that into our equation. Momentum, momentum is equal to mass times velocity. Now we know that momentum is equal to 66,000, and our mass, we know that too, is equal to 1,800 times velocity. So you can simply put that into our calculator. 66,000 divided by 1,800 is equal to velocity. And we can find our final answer is 36.6 . Now that answer is almost perfect, but not quite, because we're missing the unit. 36.6 meters per second. And that's our final answer.